This is the Aftermarket Radio Network.
Hello again. Welcome to yet another episode of Diagnosing the Aftermarket A to Z. I'm Matt Fonslow, and I got to tell you, I have the guest of all guests right now. I'm very, very happy about this. His name is Jim Kemper, and I first learned about him through IATN in the forums, and then lucky enough in the IATN chat, the chat room, where we would hang out at night and talk about a lot of theory, try to figure out not only just broken cars, but also how stuff really worked. And we were really graced with the presence of one Jim Kemper. I'll let him do his biography, if you will. And I really, first of all, I can't thank you enough for being on, Jim. I really, really do appreciate this and really miss our conversations.
Yeah, absolutely, Matt. And appreciate that glowing introduction. I probably don't deserve it, but we'll take what we can get. Yeah, we met on IATN. I think I remember the first time we met in person, I think, was probably one of the L1 test sessions way back in the day.
It was in Tennessee at the very brand new Nissan training center.
I think it was, yeah. Those were brutal sessions back in the day.
Yeah, Ryan Koyman took me for some tours. It's all country music. Ugh.
Yeah, so I my background basically is in and out of GM and Ford dealerships for probably about the first 15, 18 years of my professional life. And then I ended up going to school and work a little later in life at Colorado State University. And I worked at the National Center for Vehicle Emissions Control and Safety. And that's a what we call a federal test procedure lab. So the FTP, you probably hear us say that several times over the next few minutes or hour or so. But this is a certification level test that's given by the manufacturers and EPA just to confirm that the vehicle meets emissions. And this is what we call the gold standard of emissions tests. I then migrated to the Colorado Department of Public Health and Environment, the Air Pollution Control Division, and managed their lab. They also have an FTP lab and do today. You and I have had a lot of conversations about some of that research over the years. There's been some interesting things we've learned, and some of them we'll talk about today with aftermarket catalytic converters or catalytic converters in general. I retired in 2018 and decided to just go back to the health department at APCD, Air Pollution Control Division, and basically do research. So I'm still doing it, still working on aftermarket catalyst stuff, emissions stuff, and policy.
Awesome. Thank you again for joining me. Since its launch in 2020, the NAPA Auto Care member site has continued to evolve to keep members updated on all the NAPA programs, promotions, benefits, and other information available to help their businesses thrive. If you're a NAPA Auto Care member, visit member.napaautocare.com to access the member portal. Not a NAPA Auto Care center? Contact your servicing NAPA Auto Parts store to learn more about how to join the NAPA family. So I guess maybe just really quick, we'll cover or at least address what the FTP is. So I think most people, when you think of emissions testing, when they actually tested the vehicles, there's maybe a dyno and then an exhaust gas analyzer. They stuck something in the tailpipe, ran the vehicle under some sort of conditions. IM240 was really popular, and they would measure the gases, but it was usually measured in percent or maybe parts per million. But the FTP is different. That same thing, a dynamometer is involved. The vehicles run through a certain trace, if you will, or under varying loads, a very specific type of I don't even know what you want to call it, like a
drive trace.
Yeah, drive trace. I said trace, but drive trace is better. And they collect all the gases in bags or bags, depending on what part of the country you're from, bags. And then they measure the actual grams emitted per mile. And I think I got that right.
Yeah, you did. You did. We don't put all the exhaust sample in the bag. We do put a portion of it in there, but it's the concept is the same. When I was at CSU, I used to teach a class that was 3 days long just on the federal test procedure. So we'll probably only scratch the surface here over the next 60 seconds or so. But it is a gold standard. It's gotten much more complicated even over the last decade or so. But it will take anywhere upwards of 1 or 2 weeks to actually do the test, to do the complete test. It includes evaporative emissions. It includes mass-based emissions, where you alluded to earlier, most of the shop equipment. And we'll probably be talking a little bit about that as part of this podcast, especially when we talk about catalytic converters. That measures in concentration, as you noted, percent or parts per million, depending on the pollutant. That only really gives us a part of the picture. If you want to know what a vehicle is truly emitting, you really need to go to a mass-based test, and that would be the federal test procedure. But things obviously get much more complicated and much more costly. A federal test procedure test cell right now, and it won't do all the testing, but of the ones that at least get you through some of the basic parts of the FTP, runs about $3 to $6 million right now. So it's going to be very difficult for anybody in the repair industry to duplicate that kind of a test.
I would say so.
And I don't know if there's any other questions about the FTP, but it's expensive and it takes a long time. It takes multiple days. Now, the driving portion really isn't all that bad. It's somewhere around 30 to 60 minutes, depending on how many of these drive traces you do. It's the prep in the vehicle. We have to prep the vehicle for hours and hours, trying to get the temperature, trying to get the right fuel in it, making sure that there's no changes in the engine. So the prep is what really takes all the time. We want to make sure that we do one test on a test on one car the same as the next car. We also want to make sure that we do a test in California the same way we do it in New York or Colorado. So that's where the real time-consuming portion of it is.
So what are our options? I mean, obviously OE. So we've determined we have a failed CAT. What are our options for replacement? OE, obviously.
Right. So original equipment. You go to Ford, GM, Chrysler, Hyundai, whoever, and get whatever catalyst fits for the car. Now, you and I had just a brief conversation about this the other day. Now, that's somewhat debated, I think, in the repair industry about just which catalyst do you use. And while I don't think we necessarily need to get into the debate about it, we can certainly describe the differences. So the OE catalyst is going to be this equipment level. The emissions warranty on the vehicle. Now, this is going to be a little complicated because it's not the warranty that most of your listeners are thinking about. It's called the useful life of the vehicle, and it's actually somewhere between $120,000 and $150,000 for light-duty gas vehicles. So that's what the manufacturer has to meet. That catalyst has to perform for that length of time. Doesn't mean that your listener can go out and make the manufacturer buy a new one at 115,000 miles. That's a whole different animal. That's an 80,000-mile warranty that's for the in-use. This is what the manufacturers have to meet basically system-wide for all their models. So you can imagine that is going to be a much more expensive catalyst to produce, and in some cases, it's larger. The next option we have was created in 1986, and this is, some people call it an EPA CAT, some people call it a federal CAT, but this is an option that was created by the EPA in 1986. And if you remember back in the day, a lot of emissions programs were getting started in the late 70s, early 80s. And during that time period, and it might predate you a little bit, people took the catalyst off left and right. In fact, there was a large number of vehicles that didn't have a catalyst. And policy people were pretty concerned that when the vehicle showed up and failed the emissions test, that trying to buy all these hundreds of thousands of catalysts would create a problem, either in supply, public support, what have you. So they created this thing called an aftermarket catalyst. And basically, it didn't have to perform to the OE level. Now, keep in mind also, we're talking about the technology back in the mid-'80s. Still a pretty good chunk of vehicles had carburetors on them. They had electronic ignition generally, but they had distributors, so on and so forth. Fuel injection was just coming into play. So the catalyst didn't have to be particularly efficient in those years. It, had to work, but it didn't have to be great. So rather than meet the mass emissions test that we talked about earlier, so many grams per mile, it only had to meet a reduction efficiency. The reduction efficiency on the federal cats were 70-70-30. So it's 70% reduction for CO, 70% reduction for hydrocarbon, and eventually it was 30% reduction for NOx. That's all it had to meet. And that was fine until we get up into what we call the Tier 1 vehicles, or 1996 model year, 1995 model year in there. By now, fuel injection is fully phased in. We've had a pretty significant drop in the requirements at the federal level for what the emissions could be on the vehicle. And they really weren't working, the federal cats. Now, again, that conversation we had, I know of shops that just almost won't put on a federal cat unless they absolutely have to.
Yep, same here. Yep,
yeah.
same here.
So other shops, they say they can't afford not to put them on, So that's the debate. But a lot of shops won't, and that's why. Because they put them on and it immediately fails, or the check engine light comes on, or something like that. California developed some data, as we did at the health department in the mid-2000s in Colorado, that these devices weren't working for very long. In California, I know they had examples of a federal catalyst that had degraded basically back to zero for NOx. In other words, it wasn't reducing at all in as little as 4,000 miles. So that's only a few months of driving, maybe 6 or 7 or 8. And from an air quality standpoint, that's a serious problem. Could be a serious problem from customer service standpoint as well, especially if they have to get an emissions test, but certainly from an air quality standpoint. So California developed their own set of rules. They broke away from the 70-70-30 standard and tied it back to the original equipment standard. So now we're back to grams per mile, where we actually measure that. It doesn't matter how much it's reduced. It has to meet the standard that the car was certified to. Now, it doesn't have to do it for 120,000 miles or 150. It only has to do it function for 50,000. So because of those two items, the 50,000 mile warranty, and then the other one, I guess, is they can go across platforms. An OE catalyst tended to be fit a very specific vehicle, but the aftermarket catalysts tend to fit much broader numbers and years, makes, and models of vehicles. So between those two, they can make them pretty relatively inexpensive as compared to OE. So those are basically the three main. There's also a used catalyst that is technically legal federally. It's not legal in your Section 177 state. So you guys probably know who you are. That'd be New York, Maryland, New Jersey. There's a whole list, a lot of them up in the Northeast that are meeting California standards. You generally can't sell them there. But federally, you can sell a used catalyst. Now, having said that, I don't really know of anybody that's doing it. They're so valuable now that you try to sell them as a used. And then the final type of catalyst is the illegal ones. These are the ones you get off the internet. You look through one end and you can see clear through to the other end type of stuff. They will have no EPA labeling on them, and they're illegal to use. So that kind of wraps up the catalyst options.
So, I don't know if this will take us on a tangent, but you said something about 50,000 miles. So I can almost hear the thoughts popping up in people's heads that would give the manufacturers license to either write into their software ways to relax the algorithm or relax the monitor to widen the fill area.
So which manufacturers? You're talking about the new car, the auto manufacturers?
Yeah.
So these are only the federal and California catalysts. The aftermarket catalyst can only be installed on a vehicle after it's gone through the component warranty. That's the 8 and 80,000 miles. So it's actually illegal to install a federal or a California catalyst on something that's under that. So the manufacturers could do that, I guess. However, I'm trying to think it through here. I don't know that they really have an advantage to doing that. And the other thing they won't know is if they put it on at 80,000, did an OE go on there or did some kind of an aftermarket go on?
Yeah, I agree. So you kind of tied in a little bit of the history of the federal cats.
Yeah, we got through my first 3 bullet points already.
Yeah, that's what I was kind of thinking. So now we're on to the performance differences, the differences between those catalysts.
Yeah, so and I've already kind of alluded to it, but in as little as 4,000 miles, the federal catalysts were essentially back to engine out emissions. Here's another kind of a problem from an air quality standpoint. Some people may be concerned about that, others not. If your check engine light comes on at 80,000 miles, the performance on that catalyst may not be very bad. Now, we're going to talk about this here in a few minutes when we talk about the onboard diagnostics algorithm for catalyst prediction. The mill, and it varies from vehicle to vehicle. It's very complicated, depends on how it's certified. But the malfunction indicator lamp, check engine light, has to come on somewhere by about 95% efficiency. And for the newer vehicles, you get into the tier 2, say post 2004 model year vehicles. Some of those light will have to come on at 98% catalyst efficiency. Now, when you first put a catalyst on, it's called a green. They call them a green catalyst. They're super efficient. And that's because when they do the etching process in the catalyst production, they get all these, we can see maybe little stalactites and things are sticking out all over the place. And the noble metals stick to those. So once you fire the engine up the first few times, then some of those break off and there's some other degradation. So the catalyst will degrade a little bit in the first few thousand miles. In fact, generally for research project, we have to age them to 4,000 miles just to kind of get rid of that effect. About that time, the catalyst is probably going to be somewhere around 98 to 99% efficient. And it's going to have to stay there for the full, that useful life I talked about. If it degrades down to the point of about 97, 90, maybe even 95, again, it depends on the vehicle, that's when we get to the 1.5x or there's other 1.5 times FTP when the mill has to come on. That's only one of the many criteria of OBD. But if the catalyst does degrade to whatever point it is, and there are larger ones, some of them are 2 times, some of them are 1.75 times. I think there's even a 3 times out there. But if it gets down to that point, somewhere around 95%, 96, 97, whatever it is, the light has to come on. Now, if it's over 80,000 miles, what's the tech going to do? He's going to cut that cat off and put on an aftermarket catalyst that now might only last 4,000 miles. So from an air quality standpoint, in that case, I think my argument is, and this is not true of the ARB catalyst. The ARB catalyst will last for the 50,000. They're warranted for that. But on the federal side, my argument is it's a pretty serious air quality problem for the federal catalyst. That's why in Colorado, we only accept the CARB aftermarket catalyst. It's because of that performance difference. So it's 2 issues, really. One is it's tied back to the federal test procedure, so the emissions have to stay low, and they have to stay low for the full time of the warranty. And the warranty is increased from from 25,000 miles for the federal cap, which is what it is today. It has to be warranted to that. Although I think it's pretty clear a lot of them aren't meeting that. Or 50,000 miles for the California. So between those 2 items, it's a much better catalyst, much longer. So it has both a consumer protection aspect in it. I can't tell you the number of motorists I've had standing toe-to-toe with me yelling at me because they can't understand why they just put on a brand new catalyst and it doesn't work. And they ask me, how can people sell these things? And I really don't have a good answer for them. So those are the performance differences. They're significant.
That kind of tie in the rule with the EPA and modification of the rules from 86.
Yeah, good segue there, I guess. So EPA has been talking about changing this 1986 rule. Remember, the rule was, almost 4 decades ago on basically mostly carbureted vehicles in the fleet at the time, that it's not really appropriate anymore. So EPA, I'm stammering here a little bit because I got to think how deep I want to go into this topic. EPA used to have what was called Memo 1A, and that's what told all the aftermarket manufacturers, the catalyst manufacturers, even throttle position sensor, whatever it was, this is what you had to do. And basically, it was kind of vague, and manufacturers didn't like it, and EPA didn't really either, but they didn't want to change it. Well, they finally changed that. So we have a much better aftermarket rule now for all aftermarket parts. And SEMA, some of your listeners probably are familiar with them, especially Equipment Manufacturers Association. They have a lab out in Diamond Bar, I think, California, and they'll help you get through that process. Side by side with that is this 1986 policy that, by the way, I guess I should mention, it's a selective enforcement policy. And basically what that means is that even though, you're doing something you're not supposed to, so it's Clean Air Act says you can't do, we're not going to enforce it as long as you do X, Y, Z, as long as you do what's in our policy. So that's what the manufacturers have been following. So they've done away with that Memo 1A. They have a much better rule, in my opinion, now on that. But there's also this 1986 rule hanging out there. So they're kind of they're navigating that now. They have 3 options. They can either rescind the rule completely and just go with the new aftermarket parts rule in general, not have a specific one for catalysts. They could leave it alone, not do anything, or they could come up with a new policy, a new set of rules. And at this point, I don't know which one they're going to do. I doubt very much that they're just going to leave the existing rule in place. So my guess is that who knows how long. Like I said, it's been 10, 15 years now that they've been exploring this. But I know that they've got a couple of work assignments out there looking at costs. They've reached out to the manufacturers. So hopefully we'll get something done on this over the next 12 to 24 months. I guess we'll see.
Yeah, I guess I can't see them keeping it. Like you said, it just seems wildly inappropriate.
Seems unlikely. Here's one of the big issues, and I'm probably going off in the weeds. You can edit this out. Back in the day, they could get away with a selective enforcement policy. They basically just, put it in the Federal Register. Here's our policy, and that's it. I don't think they can get away with that today. Today's environment, my guess is they would have to go through a full rulemaking process and come out with a full rule on this, which is a much more cumbersome and can be, depending on what's going on out there or who's against it and who's for it. It can be a lengthy process. So that's a big part of what they're trying to navigate too, I believe. I mean, I haven't had anybody tell me that, but I think that's probably true. So not only do you have to modify the rule, but you got to figure out how do I make this legal in today's environment and able to survive a court challenge.
The expo everyone has been waiting for is back. The 2022 NAPA Expo is coming to the Venetian Convention and Expo Center in Las Vegas, Nevada from July 18th through the 21st. It promises to be the biggest and best NAPA Expo yet. Gear up for 4 days of business building excitement from general sessions and seminars to an enormous trade show that promises more suppliers, more space, and more products than ever before. It's all intended to help keep your business on the road to success. Industry experts will lead dozens of seminars throughout the day, and general sessions will feature speakers from a variety of backgrounds who encourage you to strive for excellence and inspire you to keep your eye on the end game. As for the trade show, with 200 NAPA suppliers and 555,000 square feet of exhibition space, you will use every minute of the doubled trade show hours to see everything there is to see. Visit with NAPA suppliers about new products and equipment, as well as the latest diagnostic and repair solutions. There will be areas dedicated to brakes, tools and equipment, heavy duty, and the NAPA store, and NAPA Auto Care, making it easier for you to locate suppliers on the show floor. The NAPA Auto Care booth will showcase the cornerstones of the NAPA Auto Care program and its elements, including branding and marketing, employee solutions, business management and development, process improvements, and gold certification. In addition to business, there will be plenty of fun at the 2022 NAPA Expo. The entertainment lineup includes country superstar Keith Urban, American rock band The Goo Goo Dolls, and the always entertaining Spazmatics, delivering the best songs and cool dance steps of the 80s. In addition to all the learning and networking opportunities, there will be an amazing lineup of prizes with a variety of vehicles from ATVs and motorcycles to cars and trucks. For Auto Care Center owners, 2022 NAPA Expo is a can't-miss event. If you are not a NAPA Expo package holder and are interested in attending, contact your servicing NAPA Auto Parts store. See you at the 2022 NAPA Expo. So that probably leads us a little bit into converter testing. And the only reason I really bring it up is back in the day, probably late 90s, early 2000s, there was a lot of debate on that, specifically the IATN forums about on-vehicle catalytic converter testing. And I think even earlier than that, mid to late 80s, early 90s, there were some CAT testing techniques, but they weren't for a check engine light, right? We didn't turn the light on for a failed or a low efficiency CAT until we were in, 95 and a half, 96 and later. And that was even on light duty vehicles for sure. So there was no CAT monitoring. The only time you were testing a CAT is when it would fail an emissions test. So you had to be in an emissions area that got tested, and then it would fail. And then there was some tests, the ones I remember being propane specifically, to get the CAT at a certain temperature, or operating temperature, and then flowing a certain volume of propane and watching an exhaust gas analyzer.
Yeah, GM came out with that.
Yeah, that was the main proponent of that, I think. Fast forward a little bit then into when we have an onboard monitor using oxygen sensors, specifically one after the catalyst. And we have people discussing how testing the catalytic converter on the vehicle, watching scan tools, specifically graphing the O2 sensors pre and post catalytic converter, and graphing them out and watching them and comparing them and being able to determine a low efficiency CAT. And maybe, just maybe, those very first algorithms that came out in that time range, that might have been a somewhat plausible notion. But I don't think it was too much later. Switch rate went bye-bye. So switch rate was literally comparing the pre-CAT oxygen sensor to the post-CAT oxygen sensor and expecting the post-CAT to change at a certain frequency less than the pre-CAT. I mean, I don't know if I'm even liable to say, but it seems to me like even as early as 97, 98, that went bye-bye. And they went to at least slightly more complex algorithms.
Yes, there's at least a couple that I'm aware of, and I haven't followed that a lot over the last, but so there was the intrusive method, and that one may be the one you're thinking about. There was a non-intrusive method, and basically it plotted out the switch rates, and this is pretty simplistic. There's a few SAE papers on it. The difference in switching between the front and the rear. So that's non-intrusive. And it just compared those, and it came up with an index. So it regressed. So if you've got a graph, if you will, and you've got a switch rate on a vertical axis with one switch rate, let's say it's the front. I'm just making this up for now. I got to go back and look at all that. And then along the the vertical axis, y-axis, you might have switch rate for the front. And along the lower axis, the x-axis, you might have switch rate for the one at the bottom. And then you would regress those two. And then you would come up with a regression line. And then you would end up coming up with an index. And it was much more complicated than that. And then the intrusive method that I'm familiar with is they would, at idle or some other point, they would actually drive the mixture. Let's see if I get this right. I think they drive it rich first, and then they look at the rear O2 voltage, and it should respond to that, right? Lack of oxygen. They then drive it lean, and then they time the amount of seconds or the time between the switching to lean and when the oxygen breaks through the catalyst. Because remember, the oxygen storage capacity, basically the oxygen just gets stored in the catalyst. And if it, depending on that time, catalyst that's bad won't have, it'll break through much quicker. And then they'll come up with a number. I'm sure there must be nuances to that or even much better ways today. However, all those methods just use oxygen storage capacity of the catalyst. If you're driving it rich and lean on the front, that oxygen stores on the substrate and doesn't get back to the back sensor. So in that sense, it also is measuring oxygen storage capacity of the catalyst. The thing I always used to like to say is that oxygen storage capacity for testing catalysts is about the worst way to do it. Except for all the others.
Yeah.
because all the others maybe. They're expensive, and you need parts, and you need expensive type of things, and so it can work. But if you look up the SAE papers on it, especially in the 80s, 90s, and even up into the 2000s, manufacturers have to jump through a lot of hoops to make it work. And it tends to work very well, OSC, oxygen storage capacity, on catalysts that are fairly highly efficient. So you might be able to get a pretty good, and again, I'm going to just kind of throw out some numbers here. I'm sure they're close, but don't quote me on them because it varies depending on, the manufacturer, and a lot of this stuff's proprietary. I'm not going to tell you what it is anyway, but it tends to work pretty good at, say, 97 to 96%, or 98 to 97%, or something like that. You can see a pretty good delta or difference between those types of catalysts. But once you get down into the somewhere, one of the statistics I saw from an earlier SAE paper was that when you get down into about the 90% efficient range, it falls apart. All of a sudden, the switch rates can be very different on a catalyst that's at 90% and a catalyst that's at 30%. So it doesn't work anymore. Now I know I've talked to many a tech that has talked to me and said, you know what, I can look at those two switch rates on the back, from the back sensor and the front sensor, and I can see it every time. And I'm not going to sit there and tell anybody not to do it. If they believe that they can, and if they can do it, that's great. My hypothesis is that the reason that they say that is that long before they've gotten to look at switch rates, say if they're diagnosing a P0420 or 430, long before they've gotten to switch rates, they've checked things like fuel control, they've checked things, make sure there's no exhaust leaks, they've made sure everything is working, and they go and they look at the switch rates, and they think, yeah, I see a difference there. They put a catalyst on it, fixes it.
Yeah.
So could be my hypothesis of confirmation bias is correct, or it could be they actually can see something that I can't. But looking at the numbers, the statistics that are in the SAE papers, it should be pretty much impossible to see that. There just isn't that much difference between a good catalyst and a bad catalyst.
Yeah, at least to the naked eye and over a short test period. And then
if you use the same algorithms and methodology that the manufacturers do, yeah, you can do that. But there's several pages of math that goes into this method, depending on the age of the car. And so to say that my eyes can see the several pages of math, I'm skeptical. But like I said, if it's working for them, keep doing it.
Because when are you going to be testing it? I mean, are we really testing these with no DTC? Are we trying to predict a failure? That seems unreasonable. So now we're checking them when we have the 420 or the 430.
That would be my guess, generally, yeah.
And so what I feel like just shoots the theory to hell, that that you can look at this stuff and determine good versus bad is you've looked at your data and you've determined the cat is bad, that the monitor, the PCM's the monitor, or whatever the control module is actually, the monitor is correct. This is a failed catalyst. We bolt on aftermarket catalyst. Usually it's aftermarket that does this. And now the customer drives off and a few days, weeks later, they're back. 420, 430 is back. You go test it now. Your same test technique. They look great. And I believe maybe especially with a carb certified cat, but maybe some of the others, if you were to take this vehicle with this new aftermarket cat and run it on the FTP, it would pass the FTP with flying colors. Flying colors. It would pass. But it can't pass the onboard monitor because, like you're saying, the math involved to come up with the algorithm to test the cat to determine its efficiency is very specific. Like whoever's writing this monitor, or people, it's probably a group, right? Not one person. They know everything about the cat. They know everything. What are the percentages, or what are the amounts of the different noble metals involved? What's on the wash coat? What's the mass of this catalyst? What's the size of this catalyst? They know all of that. That's in the monitor. And now you've put something else on there that doesn't work. You have this 420. You can't look at the data now. The data looks good. Your switch rate looks perfect. Why is this flagging a bad cat? It must be a bad PCM, right? But the cat's not right. And so that means your test technique can't work.
Certainly that's the risk, I guess I would say, is that the OBD algorithm isn't matched to the storage capacity of the catalyst. So I'm going to guess it's around calendar year 2000, EPA clarified that the manufacturers had to make sure that the light stayed out on their catalyst. And EPA's position was that they had to warranty that. I'm not sure how many manufacturers actually test that on all of. I mean, you've probably seen them. There are some federal cats that seem to fit just about every vehicle on the planet, right?
Yes.
It seems unlikely that they've tested all those for. And by the way, I'm not ragging on the aftermarket manufacturers here. We've worked really closely with them over a number of years here. I got to tell you, they don't like these federal catalysts any more than we do. And they do want, because of all the vagueness that's in the current rule with them, but they have to compete, right? They've still got to compete with people that are building catalysts that aren't good. So the manufacturers that I'm familiar with, and it's, the ones that you guys know of too, that are being sold through the major parts outlets, they don't like these things either. So the chances of them being able to test this on all of the vehicles is low, but it is an ARB requirement. So CARB, California Air Resources Board, when they get the executive order, that's the document that tells them they can sell these and what cars they fit and what the tests were done, those kinds of things. One of the things that they have to certify is that the mill stays out. So the manufacturers are testing a number of those. So you've got a much better chance with an ARB catalyst to keep the light out than a federal. In fact, so far we haven't run into one yet that turned the light on when we put a California catalyst on.
How good the onboard monitor have to do with kind of the elimination of, I guess, what would you call it? Like the dyno testing, the concentration testing. We really don't see that as much anymore. There's a lot of states that shut that down. Is that a lot to do with how good the onboard monitors were getting?
I got to think about this because, again, it could be a very long answer. Not really. I mean, it's part of it, but a lot of it has to do with what we call the model. And this is the MOVES model. It used to be the mobile model. And this is what air agencies use to determine credit for their program, how much credit they get. And basically, after 1996, you get equal credit for your program. There's other tests. There's idle testing. Some of you might be familiar with that. Some of you older guys out there remember the idle testing. You don't get the same credit for that. But if you had the IM240 program in the past, or the ASM, or the Bar 31, I mean, there's a whole list of them out there. You got equal credit for OBD as you did for the other tests. Therefore, OBD is a much less expensive test to run generally, just from a test standpoint. There are repair costs that may be a problem. So in that sense, I think that's probably why a lot of states went that way. Now in Colorado, we still do IM240 up to once a vehicle is 12 years old and older, we do IM240. Because for us, when we look at our data, the failure rate of OBD is pretty high. Some of you guys may be looking at that. You know, you get down into model year 1996, 97, those, you can see failure rates 20, 30, 40, even 50%. So all those vehicles have to be repaired. But not all of those vehicles are necessarily high emitters. So that would be a podcast probably for a whole other time. We certainly think that we believe the program structured the way it is, we probably save somewhere around 30 to 40% in total program costs by not doing OBD all model years.
Wow, that's insane.
Yeah.
Yeah, that is insane. So you're talking no code failure on a dyno test.
So yeah, so we have somewhere around 20, and I don't know if you want to get into this side of things, but the last time we ran the numbers, I ran them just a couple of years ago, somewhere around 25% of our IM240 failures have no OBD indication, meaning the light's out and they're fully ready.
Wow.
Around 30, 28, 29% of the NOx failures have the light out and they're Colorado ready. Now, our readiness, and I know this is why I hesitate to go here because I'm maybe talking about things your listeners don't really understand, readiness and OBD. And then around 30% are not ready, or close to EPA ready. In Colorado, we require O2 monitor, O2 heater, and catalyst monitor all set to ready. Most states don't. Some do, but most don't.
Really?
Yeah. So in other states, you can have up to one readiness monitor and again, different states have different rules, but generally, if it's 2000 and older, you can have up to two readiness monitors not set. 2001 and newer, you can have up to one. In Colorado, we follow that same model, but the ones that aren't ready can't be O2 heater, or catalyst. And we noticed that in one of our early research projects that if the O2 monitor isn't set, so if somebody disconnects a battery or does that kind of stuff, if the O2 monitor is not set, and there's a problem with the O2, the emissions and the mill behavior become very unstable. So the mill's on, the mill's off. Emissions are high, emissions are down. You just keep doing tests, and it's not real stable. So that's why we require the O2. That's why we require the O2 monitor to be set, and the heater. Okay, so when we were talking about federal catalysts and their performance, we did a study years ago, back in, let's see, I guess we started it somewhere around 08, 010, something like that, and went all the way up into 2013. We ended up with a total of 133 vehicles that we repaired. So they were identified as being a failure, either OBD, IM240, or both. We brought them in. We gave them a federal test procedure, the complicated test, and then we fixed them. And then we gave them another complicated test, the FTP. So again, we had 133 of those. 52 of them were tier 1. So that's basically model year 1996 to 2004. There's some phase in, and then 45 of them were tier 2, 2004 and newer. So I talked about the study, the ECS study that we did a few years ago, and it was around 2008 and maybe 2010, and it went up into about 2013. So we took vehicles that failed IM240, which is our exhaust test, or failed OBD or failed both. So these are vehicles that presumably have problems. We brought them in. We gave them the long test, the FTP, the certification test. We then repaired the vehicles and then gave them another FTP. So we could measure things like reduction, how dirty were the vehicles when they came in, how dirty or clean were they when they left, things like that. Kind of helps us understand how these various tests work. So of those, we had about 133 vehicles that were model year 1996 and newer, and 133 that we repaired. And of those, a total of 52 vehicles required a catalyst replacement, which is, pretty good fraction of the vehicles. Yeah. 9 vehicles received OE, 43 vehicles received aftermarket converters, and or a couple of them received a 49 state or California certified. So, I'm sorry, of the 43 vehicles, they either received 49 state, which is the federal, or the EPA, and California certified, but I think only 2 or 3 of those were California. So most of them were federal. And 20 of those vehicles we recruited to come back. So we've installed the catalyst on the 52. We actually wanted everybody to come back, but only 20 of them did. And they came back, and we tested them periodically, usually every few months or so. So of the 20 vehicles that did come back with the federal catalyst on them, 3 failed OBD with stored catalyst codes. The average accumulated mileage was 7,800 miles. 10 failed the FTP. They failed the certification test at an average mileage of 8,500 miles. 4 failed both FTP and OBD for an average accumulated miles of 7,100. And basically, out of the 20, 9 passed both tests at 6,000 miles average.
Jeez.
So that gives you an idea of, I think, now you can't propagate this out to the fleet. We didn't do sampling methodology that allows us to say, okay, if a shop brings in 20 vehicles and puts federal catalysts on them, they'll get the same result or similar results. No, can't say that. But I can tell you that of the 20 vehicles, when only 9 of them pass both tests when they come back, that's a problem.
Big problem.
And we checked when they came back to make sure, there wasn't misfires or, other problems with the vehicle. We actually had a couple of them that did that. So we pulled those out of this data set.
That's crazy. So crazy. So for people in non-emission states that didn't have an emissions program, part of that program is the facility. Like, so it's Colorado, that's decentralized.
No, it's centralized.
You are centralized? Okay.
Yeah. We've got one contractor that does most of the emissions test. There's a diesel program is decentralized, but the gas program is centralized.
So if you were to fail, you can go to a repair shop and they get X amount of tries to fix it?
Yeah. There's no limit on the tries. Okay. So just to be sure for your listeners, a centralized program, there's a contractor that does all the tests, and there'll be a number of stations scattered throughout an area, but it's one person that does the tests. With a decentralized program, maybe your repair shop does the tests, or maybe there's an individual that's all they do is they just do these tests, but there's one on every corner type of thing. So California is a good example of a decentralized program. Georgia's decentralized, Virginia, there's a number of them out there. And Colorado's centralized, so we just have a few stations.
Yeah, and so the ones that are decentralized that have like an IM240, the shops had to buy a dyno.
Yeah, that never happened. They came out with what they called IG, or inspection grade 240, and it basically used a bar 90 type of bench. It also had a constant volume sampler on, but basically came up with a mass reading. It was, I thought, probably a pretty good idea, but nobody ever really implemented it. So of the ones that are decentralized, they use what's called ASM, acceleration simulation mode. And it's a steady state test, and it's much simpler than trying to do what we call a transient test, which is where you're accelerating and decelerating the car. This is steady state. Just take it up to a certain speed and leave it there.
Yeah.
There are states that do that, Virginia, California. I used to know most of them, but Georgia did it. But I haven't kept up on that lately. So there's this number of them that are still doing it.
Yeah, it wasn't Massachusetts decentralized, but they had the dynos and they had the gas analyzers, and the program got switched. So these guys are sitting there with these really expensive dynos. That
goes back. I don't remember anybody doing a transient test. There were some states that did. They owned the equipment. Massachusetts may have been one of those. I can't remember. A couple of those states in the Northeast also had state employees doing the test, not a contractor. So it's the matrix on that is in multiple dimensions. Exactly. Every state did things just a little bit different.
Yeah, just enough. But part of your program, and I think most of the others, is if a solution can't be come to get your vehicle to pass emissions, the vehicle owner could file a complaint or call you guys up and have the vehicle brought. Isn't that essentially what Lloyd did? A lot of Lloyd Jones was he would work either with the repair shop over the phone or eventually.
Yep. We got 6 tech centers, and we got a number of at least six, 7 really sharp techs that will work with the repair shop. Not every state does that. And again, I haven't kept up on, Illinois used to do a lot of it. I think they've moved away from that.
Yeah, Wisconsin had like EnviroTest. I think they were involved in that.
There was a technical center and I think those were EnviroTest contractor employees that did that. I'm not sure that's still.
I don't think so. Yeah, I think it's all different now.
Yeah, in Colorado, we help. So if somebody's having trouble fixing a car or getting a car fixed.
So you might have some unique perspectives on training, I guess. Training maybe.
I don't mind talking about it, but that's another pretty hotly debated subject, right? Back in the day with some of the social media, or I don't know, I guess you can't call IATN social media, but the IATN and Diagnostic network type groups, they've got forums for that. I don't know, you can wade into those and you can see the shops that say they don't need training and the shops that say they do. And, any of the trainers that I talk to out there, they say it's pretty hard getting people to sit in the classes. So, and, I guess it's debatable whether the current system we have even encourages that.
That's kind of a good point. I know of one particular state that had, I think, a lineup of, as good a trainers as you could put together. Free. I think it was free to attend these classes for the emissions program, state emissions program. And due to low attendance, I think they just shut it down.
Yeah, there's a number of states that did that. And some of those were free. And you figure in a large metro area, there might be, of course, what's an auto tech, right? Is, guy at dealership's an auto tech? Maybe, but are all of them? Is the guy that does the oil, is he an auto tech? Maybe. But if you've got 2,000 or 3,000 auto techs in a metro area and you hold a free class with some sharp trainers and 40 people show up, which I've seen that.
Yeah. Are you kidding? Yeah. It's even as well attended as something like a Vision or the recent STX, as well attended as they may be, when you start considering the grand scheme of how many techs are out there, it's nothing. It's nothing.
But that's a whole other podcast, and one that I'm not really all that good at, because I haven't turned wrenches professionally for a long time. I'm a lurker on some of the forums and technician forums that talk about these kinds of things. So I think I can tell you what they're saying about it, but I can't tell you which ones are true or not. But you had brought up earlier about the testing at Catalyst. So we already talked about the looking at the four forms type of a method. There's also the propane method. There's a temperature delta method where you measure temperature before and after the cat. There's an old method that was taught in the mid-90s where you drove the car lean and then drove the car rich and then looked at the oxygen content. I'm trying to think of some of the others that are out there. That's probably most of them. Got CO2. But again, the problem is that none of those methods really has the resolution to test to OBD standards. Now, if you're in an acceleration simulation mode state, if you're in Georgia and you're working on a 1989 vehicle, or a 1991 vehicle, okay, for ASM, yeah, maybe one of those methods might give you the resolution you need to. But again, with OBD, if the catalyst is failing at 95%, every one of those methods are going to tell you things are working just fine, because at 95% or 98%, they are working just fine, except the emissions from an OBD standard standpoint has raised to the level where that's not acceptable anymore.
Yeah, I remember that one you're talking about where you would, either with propane or just on a test drive it really rich, drive it lean, and watch the delay between the pre-cat and the post-cat. But if I remember right, that's kind of around the time where the idea, this would be before air-fuel ratio sensors.
Right.
That the general consensus was that the three-way catalyst required excess oxygen to oxidize, and then the lack of oxygen to reduce. And that's why they were cycling the feed gas. So if you watch the O2 sensors, they would switch high to low, high to low. And the idea was, I think, for a while, the thought process was that this was on purpose so that we could cycle the feed gas going into the catalyst so that it could both oxidize and reduce. Turns out that was far, far, far from the truth.
Right. That's true.
I think the cat was the happiest, very, very, very close to stoic and like stuck there. And the reason they cycled the feed gas wasn't so much to feed the cat. It was the oxygen sensors themselves switched very closely to stoic.
Right.
And if cycling above and below gave them the best shot of averaging that stoic feed gas and giving the cat the best chance to do its job. I think I remember Burnclaw talking about how it used to be thought that these were two separate functions, oxidation and reduction. We think of them as happening independently of one another, and it turns out that's not the case either, that they happen at the same time.
That's true. It's called a redox reaction, reduction oxidation. And that reaction happens for both HCCO and NOx at the same time. Now, if you go back far enough, you go in the 80s, they actually had dual bed converters. So these are converters that had the hole, and they injected oxygen in between the two bricks. So when you tore them apart, you saw that there was a front bed and a back bed. So by default, the NOx reduction and HC and CO took place in the front bed. And then if there was some HC or CO left over, you'd put some oxygen in there and it would be good at oxidizing whatever was left over. So in that case, I guess kind of sort of there were two beds. But as a general rule, the oxidation and NOx reduction take place all through the catalyst. Now, you've always got to be careful about, never saying never, right? Or always saying always. Yep. They do have this thing called zoned catalysts. So you got zone wash coat catalysts. So they can be, and they're trying to save money on the precious metals. I don't know how many of them are out there. And again, they're somewhat proprietary, but those probably have more efficient reduction or oxidation depending on exactly where they're at in the bed. But in the end, you want that catalyst as close to stoic as possible, and maybe a smidge on the rich side. I think if you look at your air-fuel ratio PID on a lot of vehicles, it'll probably be hanging around, 0.99, something like that.
Yeah.
And that's another thing, they call that equivalence ratio on a lot of the scan tools. It's not. It's lambda.
Yeah, I know.
They just screwed up there. it reports in lambda, but equivalence ratio is the inverse of lambda. So instead of having air over fuel, you got fuel over air. So
that's the way I learned it, but I thought somewhere now it got switched where if you learned equivalence ratio was the inverse of lambda, it really would trip you up because they basically, if I remember right, didn't at some point they switch it to say equivalence ratio is the same as lambda?
Well, the math is different. So again, I haven't kept up on it. So if the engineering community has changed the convention, then I don't know about it. But if you go and read Haywood's text, which is basically the Bible for automotive engineering, for fuel control and catalysts and things like that, equivalence ratio, and I got to go look it up. I think it's fuel over air. Yeah, fuel
I think
over
you're
air.
right. In Haywood, it's the way it should be.
Yeah,
I'm almost positive somewhere though, and maybe it was just a manufacturer.
It could be, but when you look at the engineering papers, and I could try and think of the last time I read an engineering paper on lambda equivalence ratio. It's been a number of years, 2 or 3 or 4, something like that. They were still using equivalence ratio. The reason it's kind of important for engineering is that you get more resolution on one side or the other, depending on how you do it, right? So if you're doing 14:1, which is, air fuel ratio, which is lambda, you get much more, let's see, make sure I'm saying this right. I think you get much more resolution on the lean side, right? 15, 16, 17. Yeah, on the lean side. If you do it the other way, you get better resolution on the rich side. Because on the one way, you're approaching zero. On the other side, either way you do it, you're going to approach zero depending on which way you go, lean or rich. And as you approach zero, you're going to start getting less resolution. So I don't know if all that makes sense, but for probably the average listener here, it doesn't really matter whether you use equivalence ratio or lambda. It's just one's the inverse of the other. But it could be you come across something that puts even a finer point on that.
Yeah. I probably shouldn't have just thought of the question, but I think I want to say it's like a PID in the data stream, and that what you and I would qualify as equivalence ratio. It's not. It says the data PID says equivalence ratio, but it's actually lambda, and it trips people up.
Yeah, but they may have changed that. They may have fixed that at some point. I'm not sure, but yeah, it used to be wrong on a number of manufacturers.
Well, sir, I really, really appreciate your time.
That's been fun. I'm glad you invited me on.
Whatever it is, you're really good at evaporating an hour. I'll tell you that. That's
that means I talk a lot.
No, it was great. I could listen to this all day.
Yeah.
No kidding. One of my great regrets is not somehow, some way attending one of your courses either in Maryland or Colorado. Just never made it happen, and I think time ran out on me now. So, but you and Randy Bernclaw, I think Bob Halfman for a while.
Yep. Dakota. Yep.
Yep. I don't know if Matt Ragsdale did any presenting, but I know he was at a few of those.
Yeah. For presenting. Yeah. So Bob actually came out, and when I was at CSU, Randy and I did some courses out there in the FTP lab, and Bob had came out and brought some of his equipment. I don't think Coda's around anymore. I'm not sure, but he came out and did some of that stuff. But it was mostly Randy and I that did a lot of the tech courses on that.
Yeah. When I got to meet you guys out in Nashville, and you guys you're so nice to sit down and talk to me. And I mean, we talked about all kinds of stuff, but when it got technical, to be able to be so forthcoming and a lot of times too, just pointing me in the right direction, pointing me towards material. So I had already had Haywood's book, but then also the SAE papers, the CD was some, at the time early on worth the money to be able to get loads of papers at one time. I think Randy said when you're looking up papers, a lot of times you can find out that they're part of a larger book of collections, and sometimes that book was less expensive than buying the paper by itself. So I have quite a collection of SAE books simply for a couple of studies or papers. And then, of course, I got a bunch of other papers. The vast majority of them wildly over my head, but they just offer some insight on things that before I would have never thought about. So that meant the world to me. It really did.
Well, I appreciate that. And you just enjoy talking to you guys also. I mean, that was always enlightening for me to think about, I hadn't thought about that. And then we go back and start looking at it and say, you know what? It's not really what we had. I remember an old debate about what happens to volumetric efficiency as you increase altitude.
That's one of my favorites.
That debate, I think, took 1 or 2 years before we finally settled that. But we did it with math, did it with the SAE papers, but it took a long time to dig that one up. And that got started with, I don't know, we were probably sitting at a bar someplace at a conference. Somebody brought something up like that. What happens to volumetric efficiency? Because everybody would say volumetric efficiency drops as you go and increase altitude, but it doesn't.
No, it goes up.
It increases. Yeah.
Oh man,
about 10 to 12%.
Yeah, one of my very favorite threads on IATN involved you spent a lot of time, there's a lot of words, a lot of typing on your part. So I don't know if you're a super fast typer or you had somebody that would just take dictation or something, but you spent a long time on horsepower. And I mean like the horsepower, I got to be careful how I word this, because what it had to do was different vehicles, like a 4-cylinder, 6-cylinder, 8-cylinder. And I think it had to do with like airflow and the required horsepower. Well, in the same vehicle, there was only slight difference requirements in horsepower due to a little bit of weight change.
Were you talking about the old air filter, plugged air filter debate?
Well, I think that's where it ended up going to. But I think it messed with people that the airflow of a 2-liter 4-cylinder pulling a car down the road at 60 miles an hour would be the same as the airflow of a V8, although maybe slightly different due to some like internal friction and stuff like that. But it was based on the required horsepower.
That's true. Yeah. So if it takes, we'll use your example, it's too high, but let's say it takes 60 horsepower to move a vehicle down the road at 60 miles an hour. It's actually quite a bit less than that, but whatever it is, it doesn't matter if you've got a 4-cylinder or a V8 or a V10, or doesn't matter as long as it's gas. Diesel brings a whole other debate in there, whole other wrinkle. But the V8 will have a little bit more because of frictional losses. They have more friction losses. Slightly, there will be more pumping losses in a V8 because you're going to have to throttle it back to get that 60 horsepower. With the 4-cylinder, you're going to have increased throttle. So that's why we see 4-cylinders and 6-cylinders today as opposed to V8s, because you have to step into the throttle just a little bit more, lower pumping losses, and the 4-cylinder at the same speed is going to be much more efficient. It's going to be, but manufacturers need it, but it's probably 5 or 10% or something like that more efficient than a V8. It's just a V8 has more total horsepower.
Yeah, higher ceiling. Yeah, I mean, when it really boils down to it, it really sounds like I'm blowing a lot of smoke up your butt. But seriously, between like you, Randy Burnclaw, I will probably throw in John Riggle, Harvey Chan, John Thornton, maybe like Keith Lawyer and Miles Wada. You guys have given me more aha moments than I think anyone else on the planet.
Well, thanks for saying that, but it was always fun. It really was. I really enjoyed those. I don't get on there much anymore. Seems like it's just kind of gone a different direction, those places. But
yeah,
I still keep an eye on it. So if I ever see something piques my interest, I'll probably join back in. I look at it. I monitor it every once in a while.
So I think the lesson from all of this was to go back and read anything you wrote, but also for the catalytic converter stuff, if it's set to 420, 430, verify the systems that the controlling module, most likely the engine control module, is going to use for the onboard monitor. Make sure that all those systems and components are uncompromised, meaning no exhaust leaks and in fuel control, and no misfires. And then
make sure there's no O2 problems.
Yep. No oxygen sensor issues, and that the firmware is at the latest and greatest, for whatever updates.
Yep. Make sure there's no updates. Yep. Another thing that you want to add to your list is, and I'm not going to call it rare, but because it does happen, but I would say it's not common. And this is probably on the older vehicles. I don't know if it's still a problem now, but you want to check your whatever it's using for airflow control, especially if it's a mass airflow sensor.
Yeah, definitely.
The algorithm that OBD uses to test the catalyst for its performance has to be in they call it space velocity. So this is the feed of the reactant divided by either the volume of the catalyst or the mass of the catalyst. But the space velocity, those methods are pretty sensitive to that. So if your mass airflow is misreporting and you're outside of that space, it thinks it's in the space velocity, so it runs the test, but you're not. You're outside of that space velocity. You can get an erroneous 420 in those cases.
I've never witnessed it personally, but I've seen stuff put up about this was the debate about cleaning mass airflow sensors, because you guys or anybody in the test facilities would see where somebody was through history had an airflow issue, or not an airflow issue, an airflow calculation issue. Specifically with the mass airflow is contaminated, they would clean it, put the MAF back in, it would now fail emissions or set false 420s, 430s, and the fix was a new mass airflow sensor because it messed with the airflow calculation, the mass of air going into the feed gas, essentially.
What happens is it it's been so long, I can't tell you exactly whether it goes high or low. You probably remember, but when a mass airflow sensor the ones that goes bad, it either
I think it depends on the area, right? Because they have built-in reversion calculations.
But what happens is when you're going down the road at a steady speed, it's miscalculating the airflow. So the airflow is lower or higher. I think it's lower, or higher. I can't remember. But so now, obviously, that's going to throw your fuel trims off, but it trims it out. Yeah. So that might run a little bit bad for a bit, but eventually, through long-term fuel control or whatever the method is, it trims it out. So now the gas feed is correct for the catalyst, but the flow is incorrect. And when the flow is incorrect, the method that OBD uses, the oxygen storage capacity, doesn't come out right. The math doesn't work.
Yep.
And it stores as an erroneous 420. And we only witnessed it once in the lab, and it's been years ago. My impression is from monitoring some of the tech forums that it's not common, but it does happen. It probably ought to be on your list if you're the tech fixing these.
Yep. Could keep talking all night about this, sir, but I got to let you enjoy this retirement or part-time retirement. One richly deserved. Thank you again, sir.
Yeah, well, this is good. I appreciate the time and getting the word out on some of this stuff. Thanks for doing it. Thanks for inviting me. I'm honored. And I don't know, you get bored, we'll do it again sometime.
Oh, I get bored easily. So next week, no. You had a couple ideas for a part 2, so that would be fantastic if we could do that.
Sounds good. Go in the IATN archives and look around. That's a target-rich environment for finding things to talk about.
It's very, very rich environment. Thank you, everyone, for listening. This is Jim Kemper, the senior research scientist from Aurora High Altitude Emissions Research Laboratory in Colorado State Department of Health, right?
Yeah.
I hope you enjoyed listening to this, and I look forward to the next one.
Me too. Thanks, guys.
You've been listening to Matt Fanslow, diagnosing the aftermarket A to Z on the Aftermarket Radio Network. Follow Matt on your favorite listening app. He's very interested in what you have to say. Let him know what you'd like him to cover and come on the show. Matt is all for advancing the aftermarket. Find Matt Fanslow on social media and connect or on aftermarketradionetwork.com.